Hello everyone. In this video, we are going to discuss about register. A register is a device which is used to store such information. It's a group of flip-flops connected in series used to store multiple bits of data. The information stored within these registers, shift register like counters, are a form of sequential logic. This counter is going to count n number of states only. Shift register is another type of synchronous counter in which we are having similar clock pulse for each every flip-flop. You can observe that in this picture, this shift register is similar to ring counter. Why here when we connect the output to the first input, it will work as ring counter. It's called as feedback connection also. The special thing of this ring counter is it's going to count n number of states. And also, a shift register is a digital memory circuit found in calculators, computers, and data processing systems. Bits enter the shift register at one end and emerge from the other end. The two ends are called left and right. Flip-flops, also known as bistable gates, store and process the data. Now, I'm going to design the shift register or counter in whiteboard. So, see here, if you're having 4-bit counter, then it will have only 4 states. So now I'm considering the initial data of this register as 0001. And for the truth table, first I'll make clock pulse, then I put Q4 here, Q3, Q2, and Q1. These are the 4 states because it's a 4-bit counter. Here we have 4 D flip-flops. D-flop, just data transmission. We use the D flip-flop for data transmission only. So now I'll consider the initial data of this register as 0001. So 0, 0, 0, 1. So here Q1, we are having Q1 here, then here Q2, so Q2, Q3 and Q4 are 0. So, right. Then I'm considering 1 at the base of Q1. Then you need to count. So how many states required to get this same state? That means to get the same output again, like this 0001. Again, I remind the work of the D flip-flop is data transmission. Whatever data we are giving for D flip-flop when positive edge of clock pulse, the D is giving to output. Here, as we are having synchronous clock, we need to get ready with the inputs every time. So, to give first clock pulse, first I need to get ready with the input. this is the initial state, and this 0 will come to the input at the first clock pulse. And this is the clock pulse for our 4-bit shift register or ring counter. This is first clock pulse. So now I'm giving first clock pulse. What the D flop is going to do in this first clock pulse? It means just giving the input to output. For here, the first input is this 0 will come to this input. So this input is moved to the output. So this output is changed as 0 because this 0 will come to the output, and this 1 is moved to the next. Then this 0 will move to the Q3 output. Like this is the input of the third D flip-flop. So 0 is the input. So 0 is the output for the third flip-flop. Then this 0 will come to the output. So this is the state for first clock pulse. Like sorry, I done a mistake. Here the 0 will come to the output and this 0 will come to the output. So this is the first clock pulse state, and this 1 will move to the second D flip-flop. Then for the second clock pulse, this 0 will come to the input. So here 0, then this 0 will move to the output. So another 0, this 0 will move to the output. Then this 1 is the input for the third D flip-flop. So this 1 is moved to this here. Then this 0 is the input for the fourth flip-flop. So the output is 0. So here also 0, 1, 0, 0. And for the third clock pulse, this is the third clock pulse and this is the second clock pulse. For the third clock pulse, this 0 will come to the first input. So here also we have 0. Then this 0 will come to the output. So 0 is the output. Then this 0 is the input for second D flip-flop. So we can get 0 here. Then here also we can get 0 because this is the input for the third flip-flop. Then this 1 will comes to the fourth flip-flop output. Now you can see Q4 value is 1. Others are having 0 value. Then for the fourth clock pulse, this one will move to the input, first input. So here we have 1, then this one will move to the output, then this 0 is the output input for the second D flip-flop. So here we can get 0, then this 0 will move to the output for the third flip-flop, then this 0 will move to the output for the fourth flip-flop. So here we can get 1 for Q1, then others are 0. And here you can observe we get the same value as from the initial state. So the counter will stop counting. That means it's moved through 4 states to count the 4-bit data. That means for a ring counter, you want n states or n clock pulse. Then you can observe this one is moved to the next and next like this. So this is the small explanation about registers. We will meet in next video about the types of registers. Thank you.